There's a new horizon coming. You have the old traditional hydroelectric that's often equated to a dam. What we do is you have these turbines that are almost invisible to the eye, that use man-made infrastructure, that have no environmental impact, and that will be the future for this class of renewables.
This is Energy Cast, and I'm Jay Downhauer. Today we're talking about conduit hydroelectric, creating energy from man-made water infrastructures as opposed to dams. This untapped potential particularly lies under our feet where municipal water systems are in constant motion. That energy can be tapped, and as our guest today claims, this is the lowest hanging fruit when it comes to hydroelectric energy in the country. I'm a huge supporter of conventional hydroelectric, and whenever I hear that conventional hydroelectric resources are tapped out, I think back to my guest from episode 21, Cube Hydro, who told me that of the 80,000 dams in the United States, only 3% are electrified. The problem that guest pointed out with conventional hydroelectric was not the availability of locations, as you can tell there are a lot, but the bureaucratic red tape involved in getting a facility like that literally moving. In fact, that previous guest had bought facilities from other operators, I'm guessing for a nice price. Kind of reminds me of the statistic I once heard about how most country clubs aren't profitable until they're sold at a distressed price to third or fourth owners. That's what brings us to conduit hydroelectric. Like dams, the infrastructure is already there, but the headaches are far less. There's also little public outcry because the suite of technologies powering up from local water sources are embedded in the existing systems. Municipal water utilities like them because they help monetize existing assets. In some instances, my guest says the utilities were able to actually produce more power than they consumed, taking advantage of net metering and getting a check for the juice. The whole process is ultimately an exercise in energy efficiency. It's a lot like how heat recovery steam generators at power plants take waste heat to run additional turbines. And even though conduit hydroelectric involves man-made pipes and an infrastructure that likely uses mechanical equipment like pumps to get water moving around, in many states this subset of hydroelectric is considered renewable energy. Does it matter that not everything is supplied by Mother Nature? I don't think so. As our guest points out, since water is almost always flowing, this technology has far less intermittency and produces a lot more power than some popular renewables like wind and solar. Just like you can expect your sprinklers to kick on in the evening and warm shower in the morning, conduit hydroelectric is nearly always on. My guest today is Matt Swindle, president, founder, and CEO of NLine Energy, based in El Dorado Hills near Sacramento. The company started in 2010, and statistics led the team to California, where, as Matt puts it, their goal was to stick around until they owned conduit hydroelectric in that state. And he's proud to report that as of today, NLine is responsible for 91% of all sub-5 megawatt development in California. Rather than a single technology, NLine provides clients with a system of custom solutions for their particular needs. So they have plenty of project managers on staff. Can't complain about the choice if I say so myself. We also touched briefly on the California wildfire problems the state has been facing recently, and Matt's answer was the first time I'd heard that response, although the media seems to be picking up on that narrative now. I hope you enjoy my conversation with Matt Swindle. We're here with Matt Swindle, Chairman, CEO, and founder of NLine Energy. And Matt, the first question, it seems like I'm hearing more and more about hydroelectric potential from man-made facilities as opposed to dammed up lakes and rivers. You can now get energy from municipal water systems, it seems. How much potential is out there?
Jay, unofficially, there's about 2 gigawatts or 2,000 megawatts of potential from what's defined as conduits. So any man-made structure. It could be a pipeline, canal, flume, anything that had a human touch it is defined as a conduit. And the U.S. Department of Energy, through the Oak Ridge National Lab, is conducting an assessment as we record this interview. So we'll see how much of that 2,000 megawatts is actually true potential or just a reach.
You have a system here called WATER's Water to Energy Recovery System. How does that work? How is that incorporated?
Most of what we do is we recover wasted energy that exist within, let's say, a pipeline already. For every 1 foot of elevation drop, you build up 0.43 pounds per square inch, or PSI. And that's negligible at 1 foot. But when you get 200, 300, 400 feet of elevation drop, which you do encounter in many parts of the United States, you have a problem. And the problem exists for the water utilities. When you have these excessive pressure drops, they're put into a conundrum. They either have to put in a higher pressure class of pipe, which gets exponentially more expensive, or they have to blow off that pressure to allow you to have, let's say, 30 PSI, which would be good shower pressure. In some lines, mostly in the Western United States and the Northeast, you have 150, 200, even 300 PSI of excess pressure. So they put in a network of pressure reduction valves. These pressure reducing valves are in the tens of thousands across the United States, and they're just wasting energy. So we typically go in and evaluate these sites on behalf of the water agency, and we will put in a hydroelectric turbine generator that sits in parallel to the pressure reducing station, but it converts that wasted pressure into useful renewable energy and breaks the pressure just like the pressure reducing valve.
I think a lot of people in their minds are thinking, okay, water's going down a slope in a pipe, and so what you've done is you've installed a flywheel to pick up that energy from that flow. Is it as simple as that? What are we looking at here?
Not quite. We are installing traditional hydroelectric technologies that have been around for 130 years, or in some cases, we're installing newer technologies that are modular and off the shelf that are a quarter of the cost of a traditional custom-built technology. These are turbines that convert water flow and pressure into mechanical energy that turns a shaft to a generator, which makes electrical energy. And then we use the power on site, or we export it to the grid, to the electric utility, or potentially sell it to a third party, like a university or a corporate campus, like Google or Apple.
How much energy does a municipal water agency use? You say it makes a large part of their budgets.
Energy is the second highest operations spend next to personnel, and it depends on where you are in the country. Some agencies are blessed with topography, where you have surface water that may exist in a reservoir, and then the water trickles down through, let's say, a stream or a river, or it's directly piped into a pipeline. And then the water flows gravity feed all the way down. But those are few and far between. Most agencies have to pull the water in from a river or a reservoir and then pump it to a water treatment plant and then pump it again to an end user. I'm not sure if I fully answered your question, though, Jeff.
No. I think most people think it's just flowing through gravity, right? With the exception of you're pumping it up into the water tower. Now, I grew up in a very flat part of the country, but I don't think most people think there's a whole lot of energy being used with water. It just kind of naturally flows, right? But it takes a lot to get it there, huh?
There's a new horizon coming. You have the old traditional hydroelectric that's often equated to a dam. What we do and where the future is headed is where you have these hydroelectric turbines that are almost invisible to the eye, that use man-made infrastructure, that have no environmental impact, little to no regulatory path because they are benign projects, and they simply are turning that waste energy into renewable energy and profit for these cash-strapped water agencies. And where we're headed is even in some place like where you grew up, Jay, you're going to have hydrokinetic technologies where it's not the pressure and flow, but it's the velocity and flow of the water. And these are very low impact technologies that use Bernoulli's principle of lift, much like an aircraft wing. As the water passes over the blades of the turbine, they spin a rotor to a generator. And these are very good applications for canals, maybe even some rivers and streams where there's almost no interaction with biological species. And I think even in flat areas, you now have hydropower potential, and that will be the future for this class of renewable.
Matt, you've described there's a lot of different municipal water treatment facilities out there. And I take it that your water system is a system. It's a series of technologies. So I take it that one size does not fit all, and there's a lot of different ways to do this.
You're exactly correct. In our industry, there is no silver bullet. We cannot approach a particular site and hope to put one technology in the site. We made a decision as a company that we would remain, to use religious terms, agnostic on the type of technology that we would market. And we keep all technology vendors at arm's distance. So when we walk up to a site, we will evaluate it based on pressure, flow, civil and electrical constraints, any electrical or regulatory, and then that will pare us down from, let's say, 48 different technologies that are available worldwide, and then select maybe one or two that are applicable to that site. And that's been very effective for us. There is is no one size fits all. It's based on each individual site.
So your value add, and you're kind of getting into my wheelhouse, what I do day to day is it seems to me like you probably have a lot of project managers on staff, right?
Correct.
Yeah. So take us through how you work with the client to achieve the solution.
The first thing in our business is the data, water pressure and flow, is not publicly available. After 9/11, the water agencies pulled all that data back because it is considered critical infrastructure. So we have to build a bridge with the infrastructure owner. The first thing we do is a fatal flaw analysis or a feasibility study. If we hit any one of those, based on our experience, that would throw a doubt on the opportunity to develop this project, we tell our clients we simply stop. If they do get green lights or goes from that feasibility, we then do an intermediate diligence that other renewables do not do. And the biggest thing we have to prove to the water agency is we're putting a new piece of equipment in their infrastructure, and we have to prove on paper how that piece of technology will not negatively affect their primary mission, which is delivering water. If we were to disrupt the flow of water, that gets people fired. If it passes that step, then we go into a master development. And that's where we are hired by the water utility to sit on their side of the table and to do all of the non-construction related items related to putting that project in the ground. That can include design, survey, geotechnical, environmental, interconnection, regulatory filings, bidding documents for the equipment as well as the general contractor, engineering services during the construction phase, project management, construction management, and then startup and commissioning. That sounds like a lot, but the water utilities are not set up to work in the power industry. And that's a key service that our project managers provide. It's almost easier to say what we don't do. We don't provide equipment, and we're not a general contractor. Everything else falls into our wheelhouse.
And look, we've had guests on before who were in the oil and gas industry. This was for my geothermal oil wells for electricity. If you're in an oil field, you're not doing electricity. And of course, if you're doing municipal water services, you're not doing electricity either. You're right. It's a whole different world. As I'm thinking about this, I'm picturing some of the cities that you've serviced, and I'm just thinking this would make a whole lot more sense in some hilly town in West Virginia than it would in some very flat town in Oklahoma. Am I wrong, or are there some towns that are just better for this type of application?
There are two pieces to look at. One is the regulation and policy in that state, because each state is like a new planet. And then the second point is when you look at a very flat area, let's say even Delaware, as opposed to Northern California, it's just the type of technology you use. You can put a hydropower in it cost effectively that might only process 10 feet of head. And head is defined as the drop that the water falls with a very large amount of flow. And that's very typical in the East Coast, where you have lower topographic disparity, but a lot more flow because we don't have droughts for the most part on the East Coast. On the West Coast, though, you might have a lot less water, but in some cases we have projects that have 1,200 feet of drop in a pipe or penstock. So it's everywhere in between. And we have selected 13 states that are what I would consider the ripest for small conduit hydro development under 5 megawatts. You're normally exempt from a lot of the environmental and regulatory requirements that large hydro is subjected to. And to go back to your previous comment, we have been starting to get calls from oil and gas exploration as well as the frackers, because they are pulling out so much water, treating it, and then letting it feed gravity flow for a mile or two before they re-inject in the water. There are potential for hydropower recovery in pipe and oil export. Driving down their O&M costs, that could be a good synergy. I would certainly love to talk to your previous guests about some deals.
Absolutely. I'm all about it. So I'm assuming that when you're talking about fracking, now this is definitely my wheelhouse. Former life, though. Look, a lot of those water lines were black poly. They were temporary, right? So you would be incorporating into a lot of these temporary lines. Is that what you would be interested in doing?
That's very possible. The cost of the technologies now can be sized accordingly, and then it's a pressure and flow equation. What's the duration of time that the fracker, are going to be flowing water through that penstock?
Let's get into the economics here. And again, focusing more on the people you've been dealing with mainly, which was the municipal water agencies. Is there a long payback after installing your system? How should we think of this economically?
So let me answer that in three ways. I'm a firm believer in all renewables are good. However, politically in our nation, we've picked some winners and losers. Solar and wind, as of today, 2018, has an investment tax credit at the federal level and other subsidies that hydropower does not receive. The other issue is some states states politically have made arbitrary cut lines on what is defined as a renewable resource. California is a very good example. They have defined renewable hydro as 30 megawatts and below. And the reason they did that is that if you were over 30 megawatts and you said that that is renewable portfolio standard eligible, overnight California would have been 100% renewable. And it's interesting that a bill in California is actually going to the governor's desk for signature to have 100% renewables by 2045. A water utility looks at a project from a couple of lenses. Is it a profitable project? Can it produce net positive cash flow in the first year or two? What's going on in primarily the Western United States is we've had historic droughts, and water agencies have had to raise their water rates significantly. Many of the board of directors that I speak to are looking for ways to mitigate water rate increases. And one of those ways is with hydropower. Unlike any other capital improvement project, hydropower generates revenue. Many of the comptrollers and chief financial officers are qualifying for very low interest loans, leveraging their very good credit ratings. When you overlay the revenue on that, they generate positive net cash flow in the first year. And for them, that is a very big deal in these times. And then the last part is we're finding that agencies are moving forward with projects that have a 15-year or less payback or net positive cash flow in the first year. And that might sound like a long time to someone like a corporate buyer, but these hydro turbines last 70 to 120 years.
And the other thing, Matt, is that you're installing this at a municipal water facility. So unless the town turns into a ghost town, it will be around for the foreseeable future. Right?
Exactly. And everyone pays their water bills. Water and electricity are usually the two bills you pay on a monthly basis, and then you go from there.
Right. I'm curious, can this be considered a renewable resource? Because I think we think of conventional hydroelectric as it's a force of nature, right? I mean, the water comes down, it goes through a river. That's all happening through nature, I guess. But this is happening because you've got a municipal water system where things are being pumped into place. And if it were left alone, the water would not flow. So how should we think about this? Is this renewable? Is this some sort of hybrid? How do you explain it to people?
I explain it in two ways. One, there's federal and state legislation that defines conduit hydro as renewable. And then the second piece is that wasted energy, that waste pressure in this case, is going to be blown off into the environment anyway. So whether it's defined as renewable or energy efficiency, we're making that pipeline and water conveyance system more efficient by recovering the wasted energy that's just being blown off to the environment. It depends on what state you're in. A couple define us as energy efficiency, others define us as renewable energy.
Good point. I ask my guests about this a lot, especially the ones who provide a service. How do you continue to make money after you've installed your equipment and sent them the invoice for putting the system in place?
I think most developers look for a power purchase agreement or lease where they're deploying their funds or their investor funds and they're earning an annuity over the term of the PPA. What we found when we launched our company is most of the water utilities in the Western United States had a propensity to want to own that asset if it went in their infrastructure, and call that a cultural shift, maybe East Coast versus West Coast, rap wars, I'm not sure. But they, the water utilities, want to deploy their funds or third-party funds under that low-cost interest that we discussed and put it in themselves. We work for them, we put it in, we train their staff, and we hand off the keys. Now, we are retained for operations and maintenance, long-term monitoring, but we are now moving to the East Coast, and where we see those discussions are migrating to the power purchase agreement and lease. So that would be more akin to a wind and solar example. There's a number of ways to make money, but it really depends on the needs and wants of that specific water utility.
And for the people listening at home, what you're saying is in the East, you've been able to work out with these purchase power agreements, the ability to make revenue off of the electricity after it's been installed.
That's correct.
Okay. And so how much energy can you make? And I think you've said that in some cases, you're even making more energy than the municipal is consuming.
Mm-hmm. Site specific, our mean average is about 650 kilowatts, but the nameplate can be misleading, primarily because conduit hydro can be considered a near baseload generation asset, whereas wind and solar might be intermittent. When the sun is out, it's generating, but when the sun goes down, it's not. Whereas conduit hydro, particularly if it's delivering municipal water, is on 24/7. So in that case, that 650 kilowatt machine might produce something like 4 million kilowatt hours a year. About half of our sites are offsetting on-site power. And then if you don't have anything to offset power-wise on site, you sell the power back to the electric utility or to the wholesale market.
These water utilities, you'd hope, aren't in the business of making insane profits. I assume they're regulated to some extent. So does your system allow allow them to keep water prices steady, update their infrastructure? What are they doing with this money that they're saving or even making?
The first one is to apply it to any potential water rate increases. The second thing I've seen them do is hire new full-time employees because they had to lay some off. And the third thing they're doing is they're reinvesting back in their infrastructure.
Matt, it seems to me like you know a lot about finance, you know a lot about these water utilities. So tell us a little bit about you. How did you get involved in this field? You seem to have a handle on a lot of different parts of the business there.
Jay, I'm a mile wide and 1 foot deep as a chief executive officer. And another true story is with the last name Swindle, you got to try really hard to be honest. My father was the CFO of a bank, so I learned a lot from him, but we still have the stigma. I'm a U.S. Marine coming out of the wars in 2006. I was looking for something a little bit different than dodging bullets, and I came across a company that was in the alternative power sector called Enernoc. I was assigned to Southern California. That exposed me to the water utilities. We would go, after signing a contract with the electric utility, sign up individual commercial industrial customers that could load shed. If we gave them enough advance notice, they would go and turn off non-essential electric power and avert that brownout or blackout. And that exposed me to the plights of water utilities in California. The chief engineer opened up a pressure reduction vault. It looks much like a septic tank with 2 pipes coming in and 2 pressure reducing valves. And I asked what it did, and he said it really does nothing other than waste pressure to the atmosphere. And it got my wheels turning. I said, that's a lot of wasted energy. And his thought was, I have to replace these valves every 7 to 10 years. And I kept waking up in the middle of the night at 2 a.m. thinking about it. And conduit hydro has been around for a while, but our business model is just slightly tweaked in order to create that partnership with the water utilities, some unique financing, some proprietary software models that we've made to really address and develop these conduit hydro markets.
If you want to chime in on this, but it seems to me if you've done a lot of municipal water in California, I thought you might have some thoughts on maybe all the wildfires and maybe why that's happening. Do you think that that's a water management issue? Because it seems like these wildfires always seem to happen in California, and other places have trees and don't seem to have wildfires like this all the time.
Yeah, I do. It is a very complex issue, and I'm going to quickly get over my ski tips on this, but there is a very complex arrangement between U.S. Forest Service, California State Forests, and when you can cut and clear forests out there. I can't really comment. It's not really a water issue. I would classify this as a forest management issue as best as I could do it.
Okay. Last question about the company. What efficiencies are you looking for into the future to expand your portfolio of offerings?
As a result of what we did in small conduit hydro, we were introduced to a technology that does essentially the same thing of recovering the energy and turning it into useful energy, but for saturated steam applications. This would be analogous to a boiler that's producing steam. But the interesting thing is the boiler is essentially a dumb pressure vessel. So each of these commercial industrial factories put in a network of pressure reduction valves. And those pressure reduction valves are blowing off pressure just like we see in the water utilities. And in that case, we have looked at a technology that we are licensing to take to the market to recover energy from these steam applications. So we are moving into 2019 as an energy recovery company, focused not only on the water sector, but also the commercial industrial steam sector.
All right. Well, first of all, Simplify, we thank you for your service. And I'm going to finish with a lightning round of your thoughts on different energy technologies. Natural gas.
We need it. Can't get away from it. It's going to be the baseload power until we have microgrids that can self-sustain themselves.
Crude oil.
Don't like it.
Nuclear.
Need it. It's there. I think we have to figure out what we're going to do with the waste.
Coal.
Not a fan.
Wind.
Love it. More of it.
Solar.
Same. I can't get enough of that solar.
Biofuels.
Very interested in biofuels. I think that this is the one underserved market that has the greatest potential for the decarbonization of the grid, both in electric supply as well as transportation.
Hydroelectric. And let's break this up. First, conventional hydroelectric.
Serving in a role at the National Hydropower Association, the frosted side of me has to say all hydropower is renewable. The crunchy side of me says that some of that large hydro are in contentious areas. However, there is great opportunity for even more what I'd call smart and sustainable hydro, whether it's at a dam or it's in a conduit or some other application, let's say in a tidal estuary, where we can all come together and make a project that works for everyone. So not a short answer, just my editorial.
Yeah, absolutely. And then the second part, let's give an answer for conduit hydroelectric.
I wish everyone had hydropower. The unfortunate truth is we're only good in niche, discrete locations, primarily in water utilities. So we're only one piece of this overall puzzle on how do we shift from fossil fuel-based generation to more of a mix with renewables.
And then the final renewable in the group, geothermal.
Love it. I think conduit hydro and geothermal are very brother and sister relationship in that you can only generate geothermal in certain areas. Another untapped area I see is residential geothermal.
Energy storage.
It's going to be the key. If we could get cost-effective solutions that go beyond a 4 to 6 hour lithium-ion discharge rate, that will enable residential, commercial, industrial units to start defecting from the grid.
Electric vehicles.
I wish I could afford a Tesla. I would buy one right now.
Yeah, no, those are cool.
They are very cool. Big, firm supporter of electric vehicles.
I'm a motorcycle guy. Some guy at work showed me an electric motorcycle. It kind of piqued my interest.
I'll send you another video, Jay, of that same electrical vehicle when the guy throttles it back and the bike goes forward and he goes flying off the back. So
looking forward
maybe
to that.
A little too much power.
Energy efficiency.
I think energy efficiency and energy conservation are the very first places that you have to start. You don't go put a solar photovoltaic array on your rooftop unless you've changed out your fluorescent light bulbs for, let's say, LEDs.
And then finally, nuclear fusion.
Can I get some? I think we might be on the precipice of cracking the code on that, but that would fundamentally radically change what we do in terms of baseload energy supply, which will never go away.
All right, fantastic. Matt Swindle, thank you so much for your time.
Jay, thank you.
That was Matt Swindle, founder, president, and CEO of NLine Energy, a California-based conduit hydroelectric solutions company. NLine has recently become bi-coastal. He called me from his Washington, D.C. area office. You may have picked up he was comparing East Coast versus West Coast utilities. As of 2016, they've expanded into 13 states after they planted the flag in California. I want to thank Matt for his time, as well as the National Hydropower Association for pointing me in NLine's direction. All guests are sent their raw and completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. You can check out plenty of pictures online at energy-cast.com and on Instagram at hostenergy. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 46. Be sure to join us next week when we meet the university team that busted open the record for organically produced hydrogen. Until then, I'm Jay Dowenhauer. We'll see you next time.